Let's take a look at surfactants. These are the learning objectives for surfactant. Surfactant is produced by the type 2 pneumocytes, so we will focus here. This picture shows the respiratory zones of the lung. Type 2 cells and the surfactant they produce are located in the alveoli. Surfactant is made up of various phospholipids and proteins. We will look at the proteins' functions in a later slide. You can see here the type 2 cell and the surfactant lining the alveolus. Surfactant proteins play several roles, and B and C are critical in maintaining surfactant function. Surfactant helps keep the alveoli from collapsing and helps the lungs expand easily by decreasing the surface tension. It also keeps fluid from leaking from the alveolar capillary membrane. The book gives a good example of surface tension when talking about how water beads on a freshly waxed car. Alveoli are covered in a layer of fluid that is mostly water, and without the surfactant, those water molecules are attracted to each other and would cause the alveoli to collapse. Surfactant has a soap-like consistency. Soap separates the water molecules from each other and lowers the surface tension. Back to the alveoli, once the alveoli collapses, it takes a lot of pressure to reopen it, which can cause damage. So surfactant is definitely a necessary thing. Surfactant is produced, stored, and recycled. There is a continuous production in the healthy lung that keeps our alveoli from completely collapsing due to what would be high surface tension if the surfactant wasn't there. No surfactant equals a collapsed alveolus, and we call that atelectasis. When atelectasis occurs, gas exchange is compromised and the patient won't be able to exchange oxygen and carbon dioxide very well. There are several diseases that can cause surfactant destruction in adults, but replacing it in this patient population hasn't been promising. However, exogenous surfactant administered to the lungs has been a lifesaver to treat or prevent respiratory distress syndrome, also known as RDS, in infants. Preterm infants born before 34 weeks gestation lack mature surfactant, so we may give it to these babies. There are some other reasons why surfactant therapy might be needed. You can Google these conditions to learn more about them if you'd like, and we'll talk more about them in RCP 70. For now, know that these conditions are related to the destruction or immaturity of surfactant or low lung volume, so the baby might need replacement. Endogenous surfactant is what we make, and exogenous is what we administer. The natural surfactants act more quickly and are more popular, so we'll focus on those. We have a couple of choices for when we want to give surfactant. If the baby is premature and we suspect RDS will occur, we may give it as a preventative treatment. Other times, we may choose to support the baby with non-invasive treatment like continuous positive airway pressure, and in that case, we give it to the baby if the baby is not getting better on the non-invasive device. Be familiar with the dose and schedule for these natural surfactants, calfactant and baractant. Be familiar with poractant alpha as well, another natural surfactant. We administer surfactant through an endotracheal tube. It's important to warm it to room temperature. You may gently mix it if you note sedimentation in the bottle, but don't shake it. As I mentioned, it has a soap-like consistency and can get very foamy. We divide the dose into aliquots, or equally divided portions, by drawing it up into a syringe. Make sure you check the manufacturer's recommendations of how many aliquots are needed before giving it in the clinical setting. There are various devices to administer surfactant, but one popular now is the multi-access catheter shown on the left. The general technique is pictured on the right. I have posted a video showing surfactant delivery in modules, and we'll learn more about it in RCP 70. Monitoring the baby is vital when administering this medication. We may note a rapid improvement in lung compliance, which is the ability of the lung to expand and fill with air. Because this can improve so quickly, it may take less pressure to fill the lungs with the amount of volume we are giving with our bag or ventilator. If we don't make any adjustments, we could potentially cause trauma to the lung. We also need to monitor the oxygen concentration, as the oxygenation will improve quickly once the alveoli are open. The solution can back up in the endotracheal tube as well, and we may need to briefly increase our pressure or rate to ensure the surfactant goes back down into the lungs. Apnea can ensue if the tube gets clogged up. We also want to be careful not to hyperventilate the baby. Here is a table with the dose and types of surfactant, and again, be familiar with these.